Welcome back. We're looking at differences, but this time between more than two variables. So I have a continuous response with categorical variables, and we'll be looking at the idea of ANOVA and f-test. So this shows a scenario with that situation. We have some continuous variable like loan and some categorical variable with 1, 2, 3, 4, 5, 6 levels. We want to know, perhaps, is there a difference in average between the average loan and the levels, or are they all the same? So it's an ANOVA, and we get to it the same way we've looked at before, the fit y by x, and from that means an ANOVA. So we could visualize it as some number of groups with each level within that group of a mean, and we're trying to determine if they're different. In the example we were just looking at a minute ago, this shows for each of those levels the average for the level and its standard error and 95% confidence level. Here's the hypothesis for this, in which we have more than two variables, true levels that we're comparing. The null is that the mean is the same across all groups. Remember, null is the hypothesis of no difference, right? That the mean of 1 is equal to the mean of 2 equals the mean of 3, and so forth. And what we're just looking at, we would say for each of those levels of job, that the mean of one level is the same as the second, it's the same as the third, and so forth. Alternate is at least one of those levels is different. There can be multiple differences, but at least one is different. And we test that hypothesis using a F distribution. So the way that we assess whether there is a difference is with ANOVA and a p-value. So again, we've got a null hypothesis, an alternate hypothesis. Null is of no difference, right? They're equal. Alternate, at least one is different, and so if the p-value is small, we'd reject the null, accept the alternate, and conclude at least one of those means is different from the rest. Now suppose we see we reject the null, accept the alternate on this ANOVA hypothesis, then we'd like to know, well, which one is different. And so we use some multiple comparison procedure for doing that. These are our options. I'm going to illustrate using a Tukey. So we can compare means, select which method you want to use, and then we have different kinds of reports. I think this is a pretty easy one to interpret. The order differences, it's sorted based on p-value, and so you can just see with significant p-values which ones are different. The difference in self and sales, self and others, and so forth down to there. And we can visualize that with this graph. Okay, so one more example. Suppose that looking at exam scores in 3 classes, and whether there's a difference in the average exam score based on the class. So here's the null. Average is identical. Right, so the average of class A is equal to B is equal to C. Null, that we'd reject null, accept the alternate if we conclude there's a difference. So this shows those 3, A, B, and C. You can see the box plot. And so if we work through the process of using fit y by x, and we start with the ANOVA. And here's our p-value. Remember, the null is that there's no difference in the average grade in A versus B versus C. A equals B equals C. No difference. Alternate, at least one is different, so we would reject the null, accept the alternate. At least one is different. Which one? If we go to the means comparisons and say use Tukey, and then again I think this is a pretty easy one to place, way to interpret it. Look for ordered by significant p-values, and this would say there's a difference between B and C. That's it. Thanks. See you next time.